Dear students, in previous video we were discussing the regression through origin. So now we just derive the parameter beta 2 hat. Okay, what will be the formula in OLS with origin or with intercept? We already derived that beta 2 hat is equals to summation xi and yi over summation xi square. So this is the yi, this is the yi. Now here we find that the value of beta 2 hat, what the formula will look like. So we know that yi hat is equals to beta 2 hat, yi hat is equals to beta 2 hat xi, and we say that that is the estimated value of yi hat. If we put this in the population regression function, means yi is equals to yi hat plus ui hat, and solve for the value of the error term ui hat is equals to yi minus yi hat, and we just put the value of yi hat here, that is equals to beta 2 hat and xi. So what we do here, we call that this is the equation 1. We just apply the summation and square the both sides. Applying summation and squaring both sides, we will get that summation ui hat square is equals to summation yi minus beta 2 hat xi whole का square. So we are concerned with the value of multiplier the beta 2 hat. So what we do, we just take the partial derivative of this function. Just take the partial derivative of this function by beta 2 hat. Partial summation ui hat over partial beta 2 hat is equals to, just apply the partial here. I call it the dava, you may call it what you. So dava, you can also call it the curly, I call it the dava. So just taking the partial derivative, and simplifying that, you will find that that is equals to summation xi yi minus beta 2 hat summation xi square is equal to 0. Solving for the beta 2 hat, you will get beta 2 hat will be equal to summation xi yi over summation xi square. So one thing is that if you compare the both formulas, they are different. The usual formula is in deviation form is equal to summation xi yi over summation xi का square, but in case of regressions through origin, that is in the level form summation xi yi over summation xi का square. And if we talk about the variance, so what will be they like? So here we see that in case of usual regression, we find that variance of beta 2 hat is equals to sigma square over summation xi का square, and this is in the deviation. So what will be in case of the regressions through origin? So as we see in case of parameter a slope coefficient, the beta 2, the estimator, we can say that the variance of beta 2 hat in case of regressions through origin will be equals to sigma square over summation xi square. Now this xi is in level form, they are not in the deviation form. So in case of variance, we can say that in case of usual OLS with intercept, it is equals to sigma hat square is equals to summation ui hat square over n minus 2. But in case of regression through origin, it will be equals to summation ui hat square over n minus 1. So in case of degree of freedom, we are taking n minus 1. So what is the reason? The reason is that in case of regressions through origin, we are assuming that alpha I is equal to 0. It means only one penalty, one restriction is imposed, that is equals to beta 2. So that's why we are taking n minus 1. So what called the coefficient of determinations or R square of the given model? So in case of usual formula, I just here write the R square. In case of regressions through origin, that's called the raw R square. Raw R square, that is equals to summation xi yi over summation xi square and summation yi square. But in case of usual formula or regressions with intercept, they were in deviation form, but now they are in the level form. That's why this is called the raw R square. One thing, note that usually we say that the R square is positive, and usually the R square will lie 0 and 1, so we can say that. But in case of regressions through origin, the case may be different. The R square may be the negative. And the second thing is that assumption is that the sum of error term must be equal to 0. Mathematically we say that summation u I hat is equal to 0, and this hold in case of ordinary square too. But in case of regressions through origin, it is expected that the summation u I hat must not be equal to 0. The value may be something more or something less. And in case of coefficient of correlation, sorry, here I just forget the square term in case of row or square summation xi yi whole ka square over summation xi ka square summation xi y ka square. But in case of coefficient of correlation, just simply take the square root of this, and you will find that what the coefficient of correlation say. So what we have learned in case of regressions through origin, alpha must be equal to 0, as we explained in the previous lecture that the well-known finance degree kappa model and explain. And second is that the value of beta 2 had a formula is different from the simple linear regression or usual OLS. Even R square coefficient of determination is different, variance is different, variance of beta 2 hat is different, and R square may be negative, or the sum of error term may not also be 0. So regression through origin is complete.